Hey everyone, so today we have notes on section 10.2 in the book, and this section we're actually going to break it up. I'm going to break it up and cover it in 2 days. The section is just called special right triangles, but today we're just going to talk about the 45, 45, 90 degree triangles. And for a 45, 45, 90 degree triangle, that's actually an isosceles right triangle. And if you remember, probably don't remember, but from quarter one, an isosceles triangle has two sides of the triangle are equal, and then the two base angles are also equal. So because these two are 45, I know these two legs, which are the legs of the triangle, are also equal. Looking for my red pen. Remember, the hypotenuse is always across the 90 degree angle, so I labeled the hypotenuse. The other thing that's missing here, it's really not missing, I just didn't put it yet, is those two are the legs of the right triangle. Okay, and we could use the Pythagorean theorem to find a missing side length here. I think it's actually a lot of work if you use the Pythagorean theorem. So there's a shortcut, and you don't have to have it memorized, you just have to have it written down somewhere. So this is what the shortcut is, or this is what's so special about 45, 45, 90 right triangles. So here it says, in a 45, 45, 90 triangle, the length of the hypotenuse is the length of a leg times the square root of 2. Okay, so in words, that's what it represents. If we convert that into like an equation, it looks like this. I like to just write height for hypotenuse. So the hypotenuse equals leg times the square root of 2. That's pretty much what it looks like in an equation. And then in a diagram, it would look like this. These two sides are x's. We don't know what they are. They're the same though because they are equal measures. And then the hypotenuse is just the square root of 2 times the leg measure. So take a minute, pause this, copy it while we do. So here we're going to do 4 examples. 2 examples where we're finding the length of the hypotenuse in a 45, 45, 90 triangle, and then 2 examples where we're finding the measure of a leg in a 45, 45, 90 triangle. So whenever we're finding the length of the hypotenuse, the first thing you should realize is what kind of triangle is it? And because it's a 45, 45, 90 triangle, you should right away, I like to right away write the equation that we have. The hypotenuse is equal to the leg times the square root of 2. Right? That's what we use to figure out either the measure of a leg or the measure of the hypotenuse. And then we go through and just identify the different sides of the triangle. For example, this is the hypotenuse. Now we know this one's the hypotenuse because it's across the 90 degree angle. So that means over here this one's a leg measure, and then this guy is the other leg. Okay, so then I take these values and plug them into my equation. The hypotenuse we don't know, that's x. So here I put x. The value of the leg, I don't have this value, but up here it says the leg measure is 4, and technically they're actually both 4 because remember from just a second ago, when the two angles are equal, these two side lengths are equal. So I know the leg measure is 4, and that's the square root of 2. Now if there's some simplifying, we don't have anything to simplify here, but if there was, we would simplify this. So this is pretty much the answer. The length of the hypotenuse is 4 times square root of 2. And if you remember when we first started this section, we had to simplify a bunch of square roots. This is the section where we're going to use that. Okay. So let's move on to the next one. So the next one, again, it's a 45, 45, 90 triangle. Then I say, okay, I need to use this equation. The hypotenuse is equal to the leg times the square root of 2. And then I'm going to find the hypotenuse in the leg. So this one is the hypotenuse. So these two must be the legs, which they are. and they both actually have the same measure, so I'm just going to put the 5 on this side. That way it doesn't confuse us as which one to use. And then I'm going to put the information into my equation. The hypotenuse is 5. My bad. The hypotenuse is x. That's what we're looking for. And the leg value is 5. And then again, if there's anything to multiply here, we would multiply. But remember, we cannot multiply a whole number with the square root. We just kind of put them together. The only time you can multiply square roots is when you multiply a square root number with another square root number. So this would be 5 times the square root of 2. So pause it. If you need to copy this, finish copying it. I'm going to move down to the bottom examples. So in the bottom examples, here we're finding the measure of a leg. Okay, same thing. We see it's a 45, 45, 90 triangle. We're going to start off by writing down the equation. The equation, that's the relationship between the hypotenuse and the leg. The hypotenuse equals the leg times the square root of 2. Then I'm going to identify, hey, what's the leg and what's the hypotenuse? Remember, the hypotenuse is across the 90-degree angle, so I know that's the hypotenuse. So these two sides must be the legs. If this is x, this one also has to be x. Okay, so then I'm going to put this information into the equation. The hypotenuse is, I'm going to leave a little bit of space, 3 times the square root of 2 equals, leg is x, that's what we're looking for, and then bring down the square root of 2. And then remember, whenever we're solving for a variable, we just want to get it by itself. So if I want to get x by itself, I do the opposite of what's going on here. This is x times the square root of 2. So what I need to do to both sides is divide by the square root of 2. That goes away. You're left with x equals, this cancels 3. So I know both of these leg measures are 3. Let's move on to the next one. Again, it's a 45, 45, 90 triangle. So I'm like, okay, hey, I know it has a special equation. The hypotenuse equals leg times the square root of 2. I'm going to identify the hypotenuse. That's the hypotenuse. This one's a leg. This one's a leg, and they're both equal. This is x, that's x. Plug that information into the equation. The hypotenuse is 6 times the square root of 2. The leg is what we're looking for. Bring down the square root of 2. And then again, we want to get that by itself, so you use inverse operations, or just do the opposite. So we have x times the square root of 2. We're going to divide both sides by the square root of 2. That goes away. That doesn't technically go away. You're left with 1. And this is what 1x looks like. Okay. And then that's 1, and we have 6 times 1, which is just 6. That's it. Pause it. Let's get some work done. Or actually, in the next class, we'll do some work.